So anyways, but I wanted to give you a little tidbit of our own solar system so you have some idea what is what. So almost 1,000,000 times as massive as the Earth. At its center, the temperature is almost 15 million degrees. 15 million degrees, right? So compare that. If you look at the star Betelgeuse, it's going to supernova. I meant in our galaxy. Oh yeah. So Betelgeuse. So by the way, Betelgeuse is spelled as Betelgeuse. I do believe. Please do check my spelling, but it's not beetle juice like the fruit juice type of spelling, right? Betelgeuse. So Betelgeuse is a red giant. So we do expect it to supernova. Correct. It may have already supernovaed and we just don't see the light yet from it. I forget actually the distance that it is at from us, but indeed when something is as, so when the star has different stages of its life cycle. If it's closer to sort of a red giant or more in the life cycle, then we expect it to die and supernova, especially the more massive stars. Remember, why do the more massive stars die quicker? Because it needs to burn more power to stay alive. Because of course the star is doing all this nuclear power against its own gravity. If the star ran out of nuclear power, then it would collapse under its own gravitation, because stars are massive objects with a lot of mass that are of course going to try to collapse, pull down and basically collapse on itself. So there's two main things going on in a star. It's gravitation, which will try to make it collapse, and nuclear power, which it does to convert some element into heavier elements, and that's what keeps it alive. Now, the bigger the star, the more power it's going to go through, the more it needs to keep burning in order to keep burning, and so it runs out of its fuel faster. So if something is already a red giant, it's gonna be dying faster, for example, than our own sun, which is still on the main sequence. I wanted to say main sequence. So it's still definitely kind of going through its different stages, which is far from becoming a giant. Okay, so once a star kind of becomes a red giant, you expect it to kind of die at some point soon. But if it's on the main sequence, sort of what our sun is doing right now, it's just converting hydrogen to helium, and its mass is not that much. Okay, so let's keep going with the book. A little bit of tidbits about stars and whatnot for you. Our first step begins with our own sun. Hello, Jeep. I'm not sure what you're saying with that 75 thing. Oh, I see. I believe it's like 75 light years from us. So it's going to take 75 years for light to travel from it to us. So if it is 75 light years from us, so light year is a distance, it's going to take... So 75 times the speed of light is the distance it's away from us. And so it's going to take light 75 years. Okay, got it. I actually don't know, but please do double check exactly how far Betelgeuse is from us if you're interested in its supernova timing, okay? But also, at the same time, astronomy doesn't have to happen with regard to our own timelines and our human timelines. Astronomy, cosmology is more at the timeline of like giga years. So a giga is a billion, right? So billion year type of things, like the sun is around 3-4 billion years old, 4 billion years old. So that's sort of the more timeline of things. Betelgeuse, I mean, it could be a million, couple million, a few 100 million years away or something, so even the millions of years is considered short in astronomy. So just be careful when you don't hold your breath when you are expecting something to supernova, okay? But Betelgeuse, I mean, even when I was in undergrad, we were thinking that Betelgeuse will go off anytime now. So you have a point. So, but again, that's a human timeline. So, so our first step begins with our own sun, almost 1,000,000 times as massive as